Okay, next up, fraction combinations. I don't like to call it fraction addition or subtraction because, as you'll find out later, those terms really can be misleading. So what we want to start to introduce to everyone right now is that addition and subtraction is really a combination of the two. Sometimes it's going to look like an addition problem and we may kind of end up with a subtraction answer. Sometimes it looks like subtraction, we could end up with an addition answer. I'll go into this more when we get to integers, but just let's start to familiarize ourselves with this terminology now, okay? It really helps. So the fraction we'll start with is 8/12, and we're going to try to add that, combine that with 6/16. Well, one of the keys to combining is the idea that this really isn't an addition sign or a plus sign. It's a positive sign. If I were to cover this, this would be positive 6/16. Well, if I see this 8/12 there, I know that that's also positive. We know that any number that's just standing alone really has a positive sign in front of it if necessary. So let's go ahead and show ourselves that. Let's avoid those mistakes because that's one of the biggest things that we want to do this year. So here I have these two fractions. Well, as with any fraction problem, whether it's fraction multiplication or here with fraction combinations, because remember, we don't actually divide fractions. We're going to change that into a multiplication problem. So we really only have multiplication and combination. We always want to simplify that fraction first. See if you can make it simpler. Okay? Sometimes you can, sometimes you can't. But you always want to check. Well, very easily here, we should be able to see that 4 times 2 is 8 and 4 times 3 is 12. Well, that makes it very easy to go ahead and eliminate that. Next thing you know, I have 2/3 as my problem. Much simpler, okay? Well, 6/16 can have a similar result. 2 times 3 here and 2 times 8 there. There it is. There's the 1. 1 times 3/8 is 3/8. So what I'm really looking at is this new problem here. Positive 2/3 and positive 3/8. Much, much simpler, okay? Much, much easier. Always try to take it down. The one exception is if you notice that one denominator can turn into the other. Let's say we had 3/4 and negative 2/8. If that 4 can turn directly into the other denominator, I'm going to go ahead and leave this one alone and only change this one. So keep that in mind as you move through fraction combinations. But let's take our focus back up here. 2/3 and 3/8. Everybody should know by now, I need a common denominator to combine fractions. It's almost like making stacks of money, okay? When you sort through your money, you put your different denominations, your $1 bills, your $5 bills, your $10 bills, separate. We don't count a 1, a 5, and a 10 as $3, okay? We want to take advantage of each one having a different denomination and get that value for it. Well, the same idea here. We can't really just take these away from each other. They're not the same value. That would be like, mixing that 1 and that 10 and saying you have 2 instead of 11. We have to apply the appropriate value to it. So to do that, we need to get common denominators. Well, the easiest way is simply to multiply by the other denominator. Many of you will become much, much better at fraction combination as you go, and you'll be able to see different combinations that work. But no fail, what you can always do is multiply by the other denominator. Now, I can't just multiply by the 8 and by the 3. I have to only multiply by a form of 1, okay? We don't want to change this problem. We want it to still say 2/3 and 3/8, but we just want the 2/3 and the 3/8 to look a little different. Imagine when you go home, you get into your sports uniform, you get into your weekend clothes, whatever it may be, your pajamas at night. It's still you underneath. It's still you as the person. We want this to stay the fraction that we're using. We just want to put on a different outfit, okay? So keep that in mind. The only way we can do that is by multiplying by 1. You can never multiply by something else or it would change the value. Anything times 1 is itself. So we want to use that to adjust these fractions to make them have common denominators. So I'm going to use 8/8 here and 3/3 here. Notice, form of 1. Form of 1, I'm not changing the fraction's value, I'm just kind of altering what it's wearing, just making it look a little different. It's the same person underneath, the same fraction underneath. Well, here's the fraction multiplication I was telling you about. You don't realize you're doing that when you first start fractions. A lot of years you've probably gone through and never realized, hey, I know how to multiply fractions because I just did it right there in that addition or subtraction problem, which again, for us would be called combinations. 2 times 8 is 16. 3 times 8 is 24. We know that this was a positive, so we always want to give every number a sign. That's going to become very important to us because one of the biggest mistakes people make is not paying close enough attention to those signs. So let's always give each number a sign. And then every sign must have a number, but that's for later. So we'll have a positive down here still, and this will be 9 over 24. Well, now we have common denominators. That's what we've been looking for. We wanted to have the same denominator so that we have the same size pieces to put together, okay? If I change my $5 bill into 5 ones, then I can, deal with the other one. I can trade 1 for 1 instead of 1 for 5, okay? So we want to be able to have common denominators. Well, since these are on the same team, they're both on the positive team, they're going to join together, okay? Well, I see 16 and 9. 16 joins up with 9. It's like looking up at the sports field when you arrive, okay? If you had 9 people with you from your team, you look up at that field and you say, hey, there's a whole bunch of kids from our team right there. Let's go join them, okay? 9 joins the 16 who are already there. That leaves us with 25, okay? Just like if we were going to play against someone, if we looked up at that field and said, oh wait, there's the team we're going to play, we're going to battle against them. We're going to play really hard against them today, and hopefully somebody's going to come out on top. So we'll see that again more when we get to integer operations. So 16 and 9 join to make 25. Obviously they're going to stay on the same team. They're not going to switch teams. The Ravens don't show up to the field and turn into the Steelers. The Redskins don't show up and turn into the Cowboys. If you're on a team, that's the team you're going to stay on, okay? And we want to bring the common denominator along for the ride. Now, once we get here, anytime we get a fraction as a result, we want to try to simplify it, but we should remember neighbor numbers, they're already as close as they can get to each other. They can't be simplified. And even though 25 is in the numerator, we want to go ahead and leave our answers as fractions. We don't really have a use for mixed numbers at this time unless you're specifically asked. Just like we don't want to convert things to decimals unless they actually want us to. Because one of the easier things to do is fractions, as long as you kind of familiarize yourself with them. And division, decimals, that gets very tricky. And the same thing would happen when you try to change these into mixed numbers all the time. Fractions are our friend, so we want to leave them there. And that is fraction combination.